Okay, experiment 2, structure in organic compounds and stereochemistry, the use of molecular models. But this time around, I will try to teach you on how to use some of the softwares later. Okay, but the objective is for this experiment is to use model um, and to help you visualize these organic molecules and also study the stereochemistry. Okay, so as what you have learned in unit 3, although stereochemistry, I think in my lecture also I've uh, asked you to refer to some of this software as well to help you in terms of to visualize all of this, what you call that, projection. So basically what you need to do, or in this second experiment, is to use the those softwares, okay, which one that you prefer, in order to try to draw or some of the molecules that has been put in the manual. So basically the principle is as what we have learned in stereochemistry unit. Okay, so there are several characteristics of organic compounds, okay, that make their study interesting. As the first one is on the carbon. So carbon forms this very strong bond or covalent bond with other elements. So carbon can form a maximum of 4 covalent bond, okay, with other carbons, hydrogen, or other hetero atom like oxygen, nitrogen, sulfur, or it could be halogen as well. Okay, so there are tetravalent, and these organic molecules, okay, they occupy a 3D, okay, three-dimensional space. So it is how the visualization of this compound uh, is interpreted on a piece of paper. Okay, so basically by using a models, 3D models, you can actually see, you can turn it around, you can twist. Okay, that is what you are supposed to do. But then again, later I'll show you how to do it, maybe using one of the softwares. So this is all as what is in the notes. Okay, so I'm going to go straight to the procedure. So if you are in the lab, you should be using the ball and stick molecular models. Okay, but this will be substituted with softwares. Okay, and what you have to do is actually to follow these few steps, because each number will have different organic compound or organic molecules that you have to actually build. Okay, so the first one is to build methane. Okay, methane is simple hydrocarbon. So what you do is to have a methane, so 1 carbon with 4 hydrogen, and then once you have that, you should be able to answer the question below. So what is the question? This A, B, C, and D. So answer the question below in the appropriate space on the report sheet. So this will be done in your lab report. So with the model resting, so that 3 hydrogen are on the desk. So what this means is that you should arrange the position of the methane so that the 3 hydrogen will be on the desk and 1 of the hydrogen will be sticking up. Okay, it will be pointing up. So examine the structure. Okay, move the structure so that a different set of 3 hydrogen are on the desk each time. And then, is there any difference between the way that the 2 structures look? So this, for example, okay, it can be done using a software. So I'm going to stop with this for a while and go to a software. Wait, I'm going to share another screen. So there are several softwares that I have shared to you earlier when you are doing the when we are doing the lecture. Okay, we have I think I've shared to you with WebMO. You can also use what I am showing right now, which is Avogadro. The one that I'm talking about is all free, free version, no need to pay, but you have to download it from the legitimate sources, I mean from their website. So using these softwares, you can also have CamDraw, the Cam 3D, but that one is a paid version. But if you can find the crack or the free version, so that's good. Okay, I prefer to use the CamDraw, the CamDraw 3D. That's a very good software, but I don't have it in my laptop right now. So, for example, if you are using Avogadro, okay, the first part of that experiment is to draw methane. So that requires one carbon. So that is a carbon. So to draw, don't worry, I have also put a tutorial on how to use some of these softwares in your GC. Okay, so for now, just watch on how to draw. So when I put a carbon over here, when you are using Avogadro, it immediately comes with what you call carbon, hydrogen. Sorry, okay, it immediately comes with a hydrogen. So okay, it immediately comes with hydrogen. But when you are using WebMO, I think you have to draw the hydrogen individually. So you put the carbon, and then you have to add on the they call that hydrogen as well. So like this, the first step on the manual, it says to try and have the 3 hydrogen on the table. So that means that 3 hydrogen will be down. So try to work it, I mean using your mouse to be something like this. So with this, it shows that all of the 3 hydrogen, so the lighter gray is the hydrogen, the darker gray or the bigger round shape in the middle is the carbon itself. So this is how it should look like. Okay, and the procedures or the question asks you again. So if you switch among this hydrogen, meaning that you have another 3 hydrogen to be placed at the top of the table, okay, on the surface of the table, does it still show the same structure? So what you do is just try to switch, meaning having another hydrogen on top. So is it still the same or not? So you have to answer this accordingly. Okay, so I'm going to go back to the manual. Okay, then followed by, does the term equivalent adequately describe the 4 hydrogen of methane? So you have to provide an answer for that as well. So as the step goes, so try to answer, and some of it requires for you to what you call draw as well. They might ask you to draw some of these structures. Okay, and then the second, go to the second one, second procedures. Replace one of the hydrogen with colored sphere, okay, which represent the halogen chlorine. So if you are using Avogadro, okay, yeah, let me just share my entire screen. This will be easier. So if you are using Avogadro, so to change one of the hydrogen into chlorine, okay, there's a tab here on the top with the picture of a pencil, draw tool. Okay, then you go to the element, change chlorine. Okay, if you cannot find the element that you want, you go to other, then the periodic table will come out. So you select chlorine, close, and then you select any of the hydrogen. For example, I choose the top one. So I click my mouse, it will be converted into chlorine. Okay. So then you follow what the question asks you. So grasp the atom representing chlorine and tilt it to the right, keeping two hydrogen on the desk. So write the structure of the projection on the report sheet. So meaning it wants only two hydrogen on the desk. So it should be something like this. Okay, two hydrogen on the desk. So draw the projection as what you see. Okay, so you have one chlorine. So it's like a V over here and also another V at the bottom. So it can be like this. Okay, you can draw it like this. So this is the projection that it wants. Okay, and answer the rest of the question. And to step number 3, it asks you to draw another chlorine. Okay, you replace another hydrogen with chlorine, and then answer this question. Question number 4 is to draw ethane. So for ethane, you need to have 2 carbon. So if you are using Avogadro, select back carbon, okay, and replace maybe this with another carbon, the chlorine with another carbon, so immediately become an ethane. But if you're using WebMO, all of that has to be done individually, meaning you have to add the hydrogen by yourself. Okay, so then go back here and see what is the question. So write the structural formula. So are all the hydrogen attached to the carbon atoms equivalent? So draw a Sawhorse representation of ethane. So draw a staggered and also eclipse Newman projection. So this is the Newman, but this is staggered. Okay, and eclipse will be the carbon at the back over here will be twisted up. So that also can be done. And then number 5 is butene. And the last, I think number 6, the last one is, oh, sorry, not number 6. Not the last one. The second last one is cyclohexane. So cyclohexane, you can have 6 carbon. So if you want to draw cyclohexane using the Avogadro, you can go here, build. Oh, sorry, not this one. Another one you can insert. If you're using what do you call that? ChemDraw 3D, you can insert the name of compound and it can have the default structure. But for this one, you have to include all the 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay. So once you draw, what you need to do is, if it doesn't looks like what do you call that, the proper cyclohexane, sorry. What you need to do is, once you finish drawing, okay, there's a button or a tab over here which have this E. So this is actually auto optimization tool. Okay, on all of the other softwares, there will also be a function like this in which that it will correct the structure for you. Okay, for example, if I don't press this, Yeah, stop. Okay, and I draw the, let me clear back. Okay, so I draw the cyclohexane again. So it could be something like this, which is not correct. I mean, the structure is not, it doesn't look like this, right? It is not, it doesn't supposed to be 2D or flat. So what you need to do is just press this E button, the auto optimization tool. Okay, no need to change anything. The force field remain UFF. Okay, and then you just click start. Then it will, as you can see, the structure change into the uh, proper shape. Okay, so click stop and then go back to here, the navigation tools. So you can turn it around and go back to the manual. Okay, and answer some of the question. And the last one, I think number 7, if I'm not mistaken. Okay, this one on chiral molecules and enantiomers. So construct a model consisting of tetrahedral carbon with 4 different components. So you have to put 4 different groups, okay, to the middle carbon. So you have to make the carbon into a chiral center. So if like that, you draw carbon in the middle like this, but then you have to change each of these hydrogen into something else. So there are 4 hydrogen. So you could have one with OH, for example, one with chlorine, another one can be nitrogen, maybe, okay, NO2, and the last one could remain okay, the last one could remain hydrogen. So there you go, one structure with 4 different groups. Okay, so then you go back here and answer all of the, and just follow the each of these. Okay, A, B, C, and D. So that all will be put here, which is so that your report is just the answer. Okay, for this second part or second experiment, okay, no need to rewrite all of the procedure again, because the procedure is like this. Okay, you have to draw something. So just for this experiment, write the title, objective, and straight away to the result. Okay, which is number 1, methane. What is the structure, or draw the structure of methane and answer all of this question. And the material that I have put here, okay, if you go to the experiment 2, structure in organic compound stereochemistry. So I have put the tutorial video on how to use the Avogadro software, the WebMO tutorial as well, and also this one is molecular constructor. Okay, it's up to you to use any software as long as you are comfortable with it. If there are any other softwares besides this that you want to use, go ahead, as long as you can try to do or draw the structures using that software. So that is good enough. Okay, and yes, okay, these 3 are definitely free, so you can go to their, you just put Google, in Google, go to their website, and you can download. The Avogadro are the easiest to install. The WebMO for Mac, it is not a straightforward installation, so you need to use what you call the command prompt. okay, to install the software. But the Avogadro is very simple to install. They have both version for Windows, Linux, and also for Mac user as well. So depending on your PC, okay. And the web MOS, the what you call the mobile version. So if you do not want to use your PC, you can use your phone or your tablet as well. So that is all on the